Let's now begin to look at the different kinds of bonding that we do have. So I'll start with ionic bonding. So what exactly is ionic bonding? So ionic bonding is basically an electrostatic attraction that occurs between ions. Okay, so that's very simple for us to basically understand. In that, we know that we're looking at ions because it's ionic, okay? So we know what an ion is. So an ion is basically an atom that has lost or gained electrons. Okay. So for example, if you look at sodium plus and then chloride minus. This is a cation which has lost an electron by virtue of it having a positive charge. A chloride has gained an extra electron. So these are ions. So a kind of bonding that exists between such ions is what we are calling ionic bonding. Okay. So we've built an argument to say ionic bonding basically gets to form between ions. So there's an electrostatic attraction between cations and the anions. That's our first thing that we've started with. So basically, in an equation, we can write something like this. So we know that sodium has got one electron in its outermost shell. And then it's getting to react with chlorine. We know chlorine is in group 7. So it equally has got 7 electrons in its outermost what? Shell. Okay, so we understand that atoms have got desire to attain stability by observing the octet rule. Okay, that's basically what we know. So we understand that in this case, this chlorine is having 7 electrons. So it is in need of an extra electron for it to become what? To become stable. So in terms of showing what's basically going to happen is this. We know that sodium has got 11 electrons in its neutral state. In that, if you try to write the electron configuration, we've got 2 to 8 and then 1. So if you add these, will give you 11. So it's better for it to lose. It's easier for it to lose that single electron to remain with 8 in its outermost shell than gain the 7. So that's why metals tend to lose, and then it is easier for chlorine to gain 1 than lose all the 7. Okay, so expect that our result is going to be sodium will lose its electron, and then it will just remain like that. With a positive charge, of course, we can add a positive charge to indicate that it was what? It had lost an electron. And then we have chlorine basically with its 7 electrons, now gaining an extra from what? From the sodium atom. That's the result. So this can be in brackets, and then you can put the minus charge there. So it's negative charge, implying that it has gained an electron from another atom. Okay. That is in an equation form illustrating what basically happens under ionic bonding. So we can also show this diagrammatically, okay, which is very much easy as well. So if you look at sodium, I'll just show the outermost shells for the sake of time. So we understand that that is sodium, that is chlorine. So this has got, I'll use X's for chlorine. So it has got 7 electrons, okay. And then for chlorine, I'll use a dot. So it only adds the single electron there. Now what basically gets to happen is I'll show what basically happens on the bottom. So we expect that the sodium now will lose, this will go away. So what is going to remain as the outermost shell? Remember we said this electron configuration was 2, 8, and 1. So it's losing the 1 which is in the outermost shell. So what will remain as the outermost shell is the inner energy level with how many electrons? With 8 electrons. So this makes sense if you did electron configuration from atomic structure. So what is our sodium after? So we can put it also in brackets, and then I'll put a charge of a positive to illustrate that we had lost an electron. And then I'll draw another bracket, and then I'll put chlorine. So chlorine remain as it is. I'll show the crosses there, which were 7. Now, in addition to that, it has gained what? It has gained a dot from sodium. So that's what has formed that. So it has now gained a negative charge. So these two will be a single compound because they are being attracted to each other due to electrostatic attractions, due to their difference in what? In charges. So this is exactly what ionic bonding is. So if you are to break an ionic bond between sodium chloride, there's a lot of energy required to do that. So that energy that is required to break an ionic bond into its ions is what we call lattice energy. Okay, so you look at that more in details as we get to discuss thermochemistry later on in the course. Thank you very much for watching.